Hello, today we're going to talk about hurricane formation. So when it comes to tropical cyclones and their ability to form, a couple things they need. They need water and they need heat energy. That heat energy, when it comes to the ocean, the water of the ocean has to be higher than 80 degrees Fahrenheit in order for formation to happen. We've got to have that solar energy. That's part of the reason why we find hurricanes only at the tropics, is because they need to be in those lower latitudes where it's getting direct solar energy in order to produce the heat that we need. With that heat, as the water heats up, it evaporates and goes into the atmosphere, creating the warm, humid air needed in order for a tropical cyclone to progress into a tropical storm and then a hurricane. This happens through a positive feedback loop where as it rises and condenses into, or the water, as it rises and condenses into a cloud, it releases some heat energy. That heat energy warms the atmosphere in that area. And with the warm air, there becomes more evaporation. And this continues and continues to feed in a positive feedback loop, getting bigger and bigger, and the wind speeds increase faster. Wind speeds, remember, are a result of differing temperatures, and it's colder outside the storm than it is inside of the storm. When it comes to hurricanes, because they need that warm, moist water, that warm water is going to be near our tropics, as we can see here on this map. And in the northern hemisphere, all of our hurricanes follow the same general pattern as going towards the northwest, whether that's in the Pacific Ocean, over towards Southeast Asia, or in the Atlantic Ocean from Africa across to South America. The other key factor with hurricanes is having the right type of wind. With hurricanes, there can be what's called wind shear. So that's the difference between the winds near the surface and the winds at the upper level of our atmosphere. If those upper level winds are strong, then they're going to basically knock over the clouds from the hurricanes, and they'll prevent that hurricane from they'll knock over the clouds from our tropical cyclone or disturbance and prevent it from going up into a hurricane and getting larger. If it's light and those winds are very little, the hurricane will be able to progress. And now we've got our quick video.
Hurricanes are very large and intense storms. But where do these giant storms come from? A hurricane starts with the warm water found near the equator. Hurricanes typically only form in tropical regions where the ocean is at least 80 degrees Fahrenheit. These warm waters evaporate, creating warm, moist air which acts as fuel for the storm. Wind is also needed for a hurricane to form. Many hurricanes in the United States are caused by winds blowing across the Atlantic Ocean from Africa. This wind causes even more of the warm water to evaporate into the air. The warm, moist air then rises high into the atmosphere, where it begins to cool. Way up there, the water vapor condenses back into liquid water droplets. Water droplets in the atmosphere form clouds, including big, stormy cumulonimbus clouds. As the warm air continues rising upward, the winds begin blowing in a circular pattern around a center. The spiraling winds gather up a cluster of big thunderstorm clouds. Once the spinning winds reach 74 miles per hour, the storm has officially become a hurricane. Hurricanes are huge. They can be 10 miles high and over 1,000 miles across. Once a hurricane hits land, it runs out of warm, moist air and its winds begin to weaken. But the storm can still cause lots of damage to communities near the coast. Thankfully, we have weather satellites that are constantly monitoring the conditions down here on Earth. The GOES-R series of weather satellites scan the hemisphere every 10 minutes and the US every 5 minutes, keeping an eye on conditions that might cause a hurricane to form. Once a hurricane forms, the satellites can help predict the storm's intensity and track it minute by minute. This information allows meteorologists to deliver early warnings and help people stay safe. Find out more about Earth's weather at NOAA's SciJinx.
So, like they mentioned at the end, satellites are one way we can track hurricanes and get data about them. The organization in charge of tracking hurricanes for the United States is the National Hurricane Center. This is a division of the National Oceanic and Atmospheric Administration, also known as NOAA. This group is responsible for forecasting all tropical cyclone activity around North America. Not only do they watch everything in the Atlantic Ocean, but they also keep an eye on the Eastern Pacific and watch out for hurricanes that could potentially hit Hawaii. When it comes to forecasting, they're going to use satellite data. They also use aircraft. They'll send airplanes into the hurricane to collect data about wind speeds. They'll use other things such as ships, buoys, and radar. And to get that, we get maps that predict where a storm is going to go and how strong it's going to be. This image down here we can see is of Hurricane Dorian from 2019. And following, so there's little H's showing that he was a hurricane before it, and they predicted that he would become then a major hurricane, meaning a Category 3 or higher. So let's take a look at our current tropical outlook. So here is a tracking map where we have latitude lines and longitude lines. And here I've got some storms plotted. We take a look at our tropical outlook. This is all of our disturbances. And this is a 5-day outlook. So what it means is when we hold over it, it gives us information and it tells us the likelihood of something like this disturbance turning into a tropical cyclone. So this one here has only a 20% chance. Sally's already a hurricane. We also have Paulette. This one, Renee, it says Tropical Depression Renee. She is a tropical depression with a name because last weekend she was a storm. She was a tropical storm and has since been downgraded. We also have Tropical Storm Vicky and Tropical Storm Teddy. And then here's another disturbance that at the moment has a 50% chance over the next 5 days of becoming a true tropical cyclone. With any of these, we could click on them to see their potential track. So here for Teddy, they're predicting over the next 5 days. So he's currently a storm. They're predicting by tomorrow evening, Tuesday evening, that he'll progress to a hurricane with the farther out prediction of possibly being a major hurricane, so Category 3 or higher. We look at Sally. She's here in the Gulf of Mexico. Oh, give me the big picture. There we are. She's currently already a hurricane. She's going to hit the Louisiana, Mississippi, Alabama coast tomorrow morning. And then by Wednesday evening, Thursday, we'll have been down, potentially, this is a prediction, downgraded to a depression. All right. Thank you for joining me.